Hello, good evening. Can you hear me? This is Uzair Ahmed. Hello, Mr. Oliver. Can you hear me? Hello, Mr. Oliver. Can you hear my voice?
Yes,
Okay.
very well, very well, very well.
Okay. Sorry for being late. Actually, the presentation was not starting. Shall I start my presentation? I cannot hear you, Mr. Oliver. Can I start the presentation?
Okay.
Okay, I will be starting it. Can you see my screen? Please let me know, Mr. Oliver, if the sound is okay to you. I cannot hear you, Mr. Oliver. Can you hear me? Shall I start, Mr. Oliver? I think you cannot hear me because your voice is shuffling. Okay, I just got your message, but your voice is shuffling. I will start my presentation. The presentation which I have prepared is the estimating and modeling soil erosion within the Panjkora River Basin. This in district Swat, Pakistan, using revised universal soil loss equation, GIS, and remote sensing techniques under a climate change scenario. I'm Uzair Ahmed, remote sensing analyst from the Agriculture Department, Government of Khyber Pakhtunkhwa, Pakistan. Usually, as you all have known, that Pakistan is devastatedly affected by the flood in the recently. This is all just due to the climatic change and the variation throughout the world. All over the world, the countries are being affected by the global warming and climate change. So, being in agriculture department, we have seen that the flash flooding is all because of the climate change, and it is destroying the land resources and water resources as well. And land resources are our only resource on which the agriculture relies. And agriculture is the prime economy of Pakistan. So there is a need. There is a need to estimate the erosion in the Panjkora River Basin, where District Swat and District Lower Dir and Upper Din are devastatingly affected by flood. So GIS play an efficient role in estimating such problems. This is There's an overview of the soil erosion. That soil erosion is the naturally occurring process that affect all the landforms. Like in agriculture, soil erosion refer to the wearing away of the field topsoil. The topsoil is the most fertile soil on which the agriculture lies. It can be done by natural and physical forces of water, wind, through forces associated with the farming activities such as tillage, erosion, whether it is by water or winds. All the three distinct action including the soil detachment, the movement, and the deposition of the soil from one place to another. Soil erosion basically reduces the cropland productivity and the yield, which directly affecting the food security of a country. It is usually a slow process that continue relatively unnoticed, but there is a need to estimate it and to reduce the erosion to increase the production. Now, soil erosion is a global problem. Many of the world agricultural lands suffer from moderate to severe erosion. Many countries in Africa, African countries and subtropical countries are most effectively by the erosion. It is being recognized as a hazard, which is more serious in the mountainous areas and where the slope is there and making the land, converting the land into desert. So there is a quantitative assessment needed to infer the extent and the magnitude of the soil erosion problems so that effective management strategies can be adopted or resorted to increase the production of agriculture that will ultimately increase the economy of a nation. Now, soil erosion and remote sensing and GIS. So remote sensing and GIS techniques are widely used to manage the various natural resources. GIS has become a very useful tool now to assess, monitor the land surface, and because it covers a large area, inaccessible areas in a very short time. The manual and traditional surveys take a large time to evaluate such problems. So the advantages of the space and spectrum and the data availability making it efficient to analyze and manage various natural resources. Now, what is remote sensing? Basically, remote sensing is the acquisition of the information about any object or phenomena without making the physical contact. So the satellite imageries give us a vital role and play a vital role in estimating such problems. Now I will introduce you about the study area. This is the map of the study area. It basically lies in the northern Pakistan. It in the eastern Hindu Kush Mountains, northwest of Pakistan, mostly drained by the river Panjkora and its tributaries. It works its way toward the Swat River, where, as you all know, that Swat is very devastatingly affected by this flood. So river Panjkora is basically a tributary of river Swat. Its length is 113 square kilometer with a total catchment area of 5,905 square kilometer. In the study area, the soil texture varies from the loamy, sandy loamy, and clay in the nature. In the most upper parts where the soil is exposed and susceptible to erosion, it is all due to the steep slopes and the fragile slopes. Deep and rich soil occur on the moderate slope, and such areas are mostly terraced. As we all know that there are contour farming and terrace farming in the northern areas of a country that is used for the cultivation, and major crops in Rabi, wheat is grown majorly, and in Kharif season, maize, rice, and in some areas, sugar cane is there. Universal soil loss equation is widely used, a mathematical model that describes the soil erosion. But later on in 1930s, the Department of Agriculture, the Soil Conservation Services, remodified it and revised it with some little innovation by multiplying the factors together, and it became the revised universal soil loss equation, which is used now worldwide for the same purpose. It was basically a mathematical formula, but later on it was indulged in the GIS environment. The mathematical description of the revised universal soil equation is as follows. It consists of 6 factors. The 6 factors are rainfall erosivity, known as R factor, the soil erodibility, known as K factor, the topographic factor, LNS, which is combined as LS factor, and the cropping management factor is C, and the farming management practices is P factor. So the equation takes the simple product form of A is equal to R multiply K multiply LS C into P. All the 5 parameters will be first mapped individually. Later on, all the factor parameters will be multiplied in the raster calculator to identify the erosion in the area. So this is the mathematical description in detail of the RUSLE model. This is the methodology which we will adopting, and how the data. The precipitation data for deriving the R factor will be derived from the regional meteorological department. The soil map is derived from the Food and Agriculture FAO United Nations, from the digital soil map of the world, which contain 2 type of data: soil data and soil map, which contain the percentage of the sand, the organic matter, the silt, the clay, by which the soil structure and the permeability is mapped. Again, all these parameters are combined to form the K factor, the digital elevation model, from which we will derive our LS factor. And from the satellite imagery, we use the Sentinel-2 imagery in this study. And from the Sentinel-2 imagery, we have derived the C factor and the P factor, which all combine together, forming a soil erosion model. Now I will explain the individual parameters. This is the runoff, rainfall runoff erosivity factor. This is basically that tell about how much rain has been fallen on in the study area, and what is the ratio of the slope to rainfall. The higher the rainfall and the steeper the slope, the erosion will be high. Like it is directly proportional to the product of the total kinetic energy of the storm times at its maximum 30-minute intensity. In 2020, previously to this study, the R factor is estimated as 38.83 to 111.863. This is the another factor known as K factor, which is soil erodibility. It is derived from the FAO digital soil map, in which we have studied that how the land is susceptible to soil erosion and the rate of runoff of the water flow, and is measured under standard unit plot condition. The soil high in clay have the low values, but the soil which is low in clay have the high K values. Porous texture such as the sandy soil have a low K factors from ranging from 0.05 to 0.02 because of the low runoff, even though these soil are easily detached. So this factor usually tell about the soil surface and the structure of the study area. This is the length slope factor, in which we identify that how much the length and the slope of the specific area participate in the erosion. Like we can see that in this map, you can see that the red marks usually show us the high slope, while the yellow is the moderate slope and the green one is a very less slope. So the topographic factor known as slope length factor reflect the effect of the topography in the soil erosion. An increasing slope gradient and the slope length cause the high overland flow of the velocities, and therefore high erosion, resulting in increased LS factors. So the study reveals that LS factor in the study area is from 1.346 to 31.206. In the cover management factor, we usually identify from the satellite imagery that what is the cover here. First, we derive the land use map of the study area. For this, we use the Sentinel-2 imagery. The imagery was reclassified into 5 classes comprising of water, barren land, urban land, forest, and agricultural land. And based on that, we give the standard values to the each class. And the cover management factor was used to reflect the effect of the cropping and the management practices on the erosion rate. It is the factor used often to compare the relative impact of the management activities on the conservation of the plan. It is usually affected by the crop rotation, the time of the cultivation, and other management schemes such as the farming practices which usually we do in our areas reflect the cover management. And the study reveals that C factor in our study area comprises from 0 to 1. This is the last factor, one of the most important factor, known as support practice factor, known as P factor. This is actually what activities like management activities done in the field, like contouring, strip contouring, the tillage, the tractor and plowing on the fields, and the detachment causing by such activities, influence of that in the erosion, like it is reflecting the impact of the support practices, the average annual erosion. It is the ratio of the soil loss with the contouring or the strip contouring, that how straight rows farming can affect the erosion. And the study shows that the P factor in our areas from 0.55 to 1. All the parameters derived are then multiplied with each other in the raster calculator in ArcGIS 10.8 software, and the final map was mapped showing that all the parameters multiplied, showing that erosion is then the erosion resulted was reclassified into 5 classes from low erosion, moderate erosion, high erosion, and very high erosion. You can see that the yellow is low erosion from 0 to 5 ton per hectare per year, and from that 5 to 10 this is moderate, and then 10 to 20 tons per hectare it is very high erosion. And you can see later on that the maximum erosion in our study area is 37.43 tons per hectare per year in the Panjkora River Basin. So what we concluded from this study is that the resident of the area living nearby the Panjkora River, because the rest of the area is mountainous, and do agricultural practices nearby the river side, which is affected by the erosion, leading to the loss in the productivity. Usually the erosion in our area is because of water. The rainfall occur, and with the steep slope, it flow away, washes away all the soils toward the river. So which ultimately leading to the loss in productivity and food quality, which is now a risk to the Pakistan national food security. So it is also identified that the maximum the erosion in the study area is by the river Panjkora, and the highly soil loss affected areas are largely confined to the close vicinity of the settlements near side the river, and thus prone to the encroachment. So moreover, the exposed areas are prone to overgrazing, may lead to severe erosion in the near future, highlighting the implementation of strengthened conservation practices in the study area. The same study was submitted to the government of Pakistan, and this year the government have taken the initiative of conserving the soil and water resources of the areas throughout the Pakistan to reduce the loss in the productivity and to improve the agriculture. Such studies are diversely needed across the world, because this is one of the effect of the climate change. The diverse climate change is affecting such situations. So this is of very need to do such studies and estimate the erosion throughout the countries where it is needed. Mainly the tropical region and subtropical region of the world is directly affected by such erosions. So we need to estimate them and to solve the problem for the stakeholders. Thank you. If anyone have some questions. Yes, Mr. Oliver, is there any question?
Yes, Mr. Musub, do you hear me? Do you hear me now? Hello?
Hello.
Yes, Mr. Mosam.
Sorry, I'm just.
Actually, Mr. Mosam, there is some problem in your mic and I can't hear you clearly. Can you please write your question in the message and the chat option, please?
Okay.
So I can get your question directly, because there is some issue in your mic. I can't listen you clearly. Oh, sorry, Mr. Mosab. Can you? Yes, please. Your question is. Mr. Oliver, is the presentation was visible, or there was some issue at my end? Please let me know. Yes, sure. I can resume if he say from which slide, Mr. Mosab. I will give you the brief about the slides. You can see them and let me know when you get it. Can you see my slides now, Mr. Mosab?
Yes.
Yes, basically the study we have conducted is about Panjkora River Basin. The soil erosion estimation and modeling. As we all know that the world is affected by the climate change and global warming. So, due to the climate change and the global warming, the flash flooding and rainfall occur, and Pakistan was directly affected by the climate change and flash flooding, which washes away the maximum land resources of the northern KP. So, this study was conducted to identify that how much ton of the soil is eroded from the Panjkora River Basin in the North Pakistan, and that was estimated using the RUSLE model and GIS and remote sensing techniques. Soil erosion is the detachment of the top soil of the earth's surface, which lead to the decline in the agricultural productivity. So nowadays, due to the global warming, the soil erosion is a global problem, and the tropical and the subtropical areas of the world, mainly the African countries and the South Asian countries, are very affected by the soil erosion. So there is a need that we shall, all the GIS professionals across the world should take the initiative to identify the such problems and give the information to the stakeholders so they can make effective management strategies to restore it and to reduce the erosion so that we can increase our productivity. For which reason the GIS and remote sensing techniques were used. They play a vital role in managing the natural resources across the world, and it is a very efficient tool for accessing such activities. Basically, remote sensing is the acquisition of information about some object without making any physical contact with that object, and it play a vital role in accessing the areas which are far inaccessible by human being. This is the study area map of our study where we conducted in the northern Pakistan. It lies in the eastern Hindu Kush mountain range, which is usually drained by the river Panjkora and its tributaries. The soil of the study area texture vary from the loamy, sandy loamy to the clay in nature, and there are very excessive rainfall. So the excessive rainfall affect directly the study area, and the parameters which we have taken into account are the lies in the revised universal soil loss equation. It is a model derived by the Department of Agriculture, United States of America, to assess the soil erosion. Previously in 1960s, it was a mathematical model, but later on it was indulged in the GIS and remote sensing environment, so we can efficiently identify such problems. This is our methodology flowchart. The precipitation data can be directly taken from the regional meteorological department. The soil map you can take it from the FAO, United Nations digital soil map. The elevation model can give you the LS factor and the satellite imagery, or whichever you can use. You can use Landsat or Sentinel, or it will be better if you can use high resolution imagery that will give you the C factor and the P factor. All these 5 parameters will be combined in the GIS environment, which will give you the erosion estimation of the soil erosion model. Now, these are the parameters. The first parameter is the rainfall runoff erosivity, that how much rain fallen in the study area and how can they affect the erosion. This is only an individual parameter. Another parameter is the soil erosion and the soil erodibility, known as K factor. It can be derived from the FAO digital soil map, that how the soil structure, like sandy slope or it is clay, the soil in high clay formation can give you low K values, while the content of clay is low can give you high value of the K model. Another factor is the length slope factor. It is derived from the digital elevation model, so that how the length and the slope of the area can affect the topography, can affect the soil erosion. So it is that. Another parameter which is important, that is cover management. The image for this, the image of Sentinel-2 was classified using maximum likelihood and train support vector machine, in which it was classified into 5 classes of water, agriculture, forest, urban, and barren. and then the standard values were given from different international journals, literatures, give you the cover management, that what is the surface cover of the study area now and how it infects into the soil loss potential. What is the soil loss potential of such cover? Then it comes to one of the most important parameter known as support practices. Such practices like farming, contouring, tillage, plowing in the field, which causes the detachment of soil, how they affect the erosion. So that can be identified in the support practice factor. Later on, all these 5 parameters are multiplied in the raster calculator in our GIS and give you the final erosion model, which is reclassified into 5 classes known as low erosion, moderate erosion, high erosion, very high erosion, and severe. So from 0, it is low erosion. From 0 to 5, that is moderate erosion. From 5 to 10 tons per hectare per year annually is known as high erosion. And the maximum erosion which we can see, that is 37.43 tons per hectare in the study area. The red line shows you, so we can see that the study area have a moderate erosion, maximum moderate erosion from 5 to 10 tons per hectare, which is very high and which can lead to the decline in agriculture productivity. It is concluded that the maximum people rely here in the area on agriculture. The major crop cultivated in area in Kharif season is rice, maize, and some areas have sugarcane. While in Rabi season, we have wheat here. So causing it, the rainfall and the soil pattern here directly affecting it. So there is a need to access them, and we concluded that such activities can be initiated by the government to reduce the erosion so we can improve our productivity, because now the food production and the low food production is at risk, and that is causing the national food security risk. So we need to, the GIS professionals all over the world need to access such problems in their own areas and give the solution to the government so they can take the initiative to reduce the erosion and to improve the crop productivity. That's all. Thank you. If you have any question, please let me know. Yes, Mr. Mosab, is there any question?
Thank you, Mr. Azir.
Yes, you're welcome.
I think this is full informative presentation. Thank you for all this information about soil erosion. My question before I attend your presentation is about how we can use the satellite image to extract the information about soil erosion. Now the idea is clear, but I come with another question. So is it that the spatial resolution or the resolution of satellite image is the effect that the result of final map of soil erosion?
Yes, usually it depends upon the study area, that how much study area if you have. If you are working on a one state or a one province, then a 30 meter resolution or a sentinel, a 10-meter resolution can work perfectly. But if you are working on a short area, then you can go for a high resolution of imagery.
Yeah. So all the use of satellite image is to extract two factor. If I'm right, the C factor and
P factor.
Yeah, like the land cover maybe, and the crop land type, I think.
Yes. The cover management factor known as C factor and the support practice P factor are derived directly from the satellite imagery, while the rest of the parameters are derived from the different sources.
Yeah. Thank you very much. I think that this is a very full of information presentations. Thank you for your effort.
You are welcome, and you feel free if you can ask some question in detail. You can contact me directly on the Slack. help out if you want to have some study, some research in your own study on your own area. I will help you. Please feel to contact.
Yeah. Thank you. I think from the flow chart of this of study, there is more like equation and so on. So if we go to details, I think we need your support. So
yes, I will. I'm always available for help. Thank you.
Yeah, thank you.
Thank you, Mr. Oliver. Thank you. Yeah, thank you, Mr. Mosaf. Mr. Oliver, is it okay? Shall I leave or any other question? Please let me know, Mr. Oliver. Is there anything remaining? I think the presentation will end in 1 minute. Okay, thank you, everyone. Thank you for listening me and giving your valuable time. Thank you so much. Have a good day.
Thank you.